Hi everybody. I will just talk you through questions 4, 6 and 7. Number 5 is missing. So question 4, here is your circuit, and what we are asked to do in part A is calculate the resistance of each of the parallel branches. So these are your parallel branches, and then calculate total resistance. I've just done the whole thing in one step. So this parallel branch, the resistance is 1 over 4 plus 1 over 4 and 1 over that, and this is the one in series, and this is your next parallel branch. So this is the same as 4 to the power of negative 1 plus 4 to the power of negative 1, the whole thing to the power of negative 1 plus 3, and the same thing for this parallel branch. So when you add all these three, you get 6 ohms. So that's a total resistance of the whole circuit. Then the next thing is circuit current. The circuit current depends on total resistance and battery voltage. So your battery voltage is 12 volts, and your circuit and the total resistance is 6 ohms. And so that is how you get your current, which is 2, so 12 divided by 6. And then the next question is, what's the voltage across the 3 ohm resistor? So you got all the current going through here. So you got 2 amps is your current, so all of them there. So 2 times 3, you get 6 volts there. And the current through each branch. So in order to get the voltage across the 4 ohm resistor, so there are 2 of them, so the current actually splits into 2, so it goes 1 amp there, 1 amp there, and so voltage is current times resistance, so 1 times 4, you get 4 volts. And then and E is what is the current in the 2 ohm resistor. So you got 2 amps. Because the resistor is identical, the current actually splits evenly, so you get 1 amp through each of them. And then the next part is another 3 ohm resistor is added in parallel with the existing 3 ohm resistor. So now the circuit becomes like this, okay? And then it says what happens to the current drawn from the battery. The moment you add something in parallel, the total resistance decreases, so you get bigger current from the battery. So current increases. And what happens to the voltage across the existing 3 ohm resistor? Because there's one more resistor in parallel, even though the current increases, it actually splits into 2, so not all of it goes through the 3 ohms. So actually the voltage across the 3 ohm resistor will be less, or it'll decrease. So that was question 4, and then moving on to question 6. So there's 2 unknown resistors, they have the same resistance. And because they have the same resistance, you've got the current of 2 amps, that means it splits evenly, 1 amp, 1 amp. Now A is calculate the total resistance of the circuit. So for the total resistance of the circuit, you just need total voltage and total current. So when you divide them, you get 5 ohms. And then calculate the voltage across the 3 ohm resistor. Voltage is current times resistance. You multiply those two and you get 6 volts. And so what is the voltage across each branch? So it's the battery voltage minus the voltage across that. The voltage across this is 6 volts. So 10 minus 6, you get 4 volts. And then if that is, so if each of these had got 4 volts across each of them, your resistance is voltage divided by current, so it's 4 divided by 1, which is 4 ohms. And that is how you get that. And then part E is if another identical resistor is added in parallel to the unknown, what would happen to the current through them? So the moment you add one more resistor here, the total resistance will decrease, so this current is going to become greater than 2. The current from the battery will increase. That means the voltage drop across that will increase. It'll be a number bigger than 6. So what's left over is 10 volts minus the number bigger than 6 will mean there is less voltage across each branch. Now the resistance hasn't changed, so V is equal to IR. So if the voltage is less but the resistance is the same, the current will be less. So you get less current. Moving on to the last question. You've got 2 unknown resistors and they have the same resistance. Here's your circuit. Calculate the total resistance of the circuit. So it's 15 divided by 3, and that's how you get the 5 ohms. And what's the voltage across here? 3 times 3, you get 9 volts. So what's left for each branch is 15 minus 9, you get 6 volts. So if the voltage across that is 6 volts, the voltage across that is also 6 volts. So you can get the current through here, which is 6 volts divided by 4 ohms, which is 1.5 amps, and that's how I get that. And so the current, so if there's 3 amps, if 1.5 goes there, the remaining 1.5 goes there. So the current through the middle branch is 1.5 amps. So the total resistance of that branch is voltage, which is 6 volts, divided by 1.5, you get 4 ohms. That's this plus this is 4 ohms, so each resistor is 2 ohms.